Hello, my wonderful viewers. Welcome once again to Frequency Online Maths. Today we are going to solve this math problem. We are going to continue from where we stopped. This is number 3 of the world, past question. Prove that for all natural numbers, 1 plus 3 plus 5 dot 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 2n minus 1 is equals to n squared. This type of math is called what? Mathematical what? Induction. This mathematical induction is for people that like what? Argument. In mathematics, so many people like what? Argument. So this mathematical induction is telling us about if you say that this thing is true, denote it and prove it yourself. If you say that one, that if you write one, for example, that if you write one, that if you have 2m plus 5n plus z plus k, that one is equal to this thing. Somebody will tell you, are you sure? You say yes. Somebody will tell you, I don't agree. You say, okay, now what? Let's see. So now what? Let's see. I'm trying to convince you. Just what? Electrical engineering students, I'm trying to do what? Convince you. So let's write solution. Let n denote the following. So we're going to just repeat this. 1 plus 5 plus infinity 2n minus 1 is equals to n squared. Now the argument comes. We need to show. Tell your brother we need to show. Tell him now, I'm not hearing me. Say we need to show. We need to show that P of 1 is true. Alright, arguments people, come over. There's an argument here. I don't know how to prove it. We need to show that P of 1 is true. Now let's prove it. They are not telling us that if this one, they are telling us that this one is equal to this thing here, and this one is equal to this thing here also. Another person said, no, I do not agree. So what do you want me to do? Okay, let's solve. So they said 1 is equals to n squared. Let's check. Remember, P of 1, let n denote the following. This n is what? The number 1, 2, 3, 4, 5. It's going like harmonic words, series, in series. So we have P of what? 1. So anywhere we see n, we put what? 1. We want to know whether if this thing is equal to what? This thing. So we have 1 is equals to 1 squared. And 1 squared is equals to what? 1. Prove. Wow. You can also use it and prove this one, but there's no time. So let's prove the second one. We have 1 plus, another person will say, oh, I prove this one, that this one plus this one is equal to this thing. I'm tired. So you say, oh yeah, let's prove it. Is equals to what? N squared. Remember, we are now on the what? Second one. So we need to show that, okay, let me write again. We need to show that, okay, let me just leave it. We need to show that P of 2 is true. So let's go. We have 1 plus 3 is equals to, let's use this one this time around. Okay, let's use it. 2n minus 1. 1 plus 3 is what? 4. Our n is what? 2 minus 1. Are you seeing it? So we have 4 is equals to 2 times 2, 4 minus 1. No, that means we cannot use it. Do you see? We cannot use it. We are allowed to use what? Only this one. Let me do fast and clean it before these people that are doing arguments will come now. I say, you see, your arguments have done what? Failed. So let's use this one, please. This one we know about. So we say 1 plus 3 is what? 4. So 4 is equals to 4. Proved. This math is all about what? Arguments. So don't mind me. If you say it's not all about what arguments, okay, I can use this thing here. In this place, I did 1 is equals to 2 parenthesis 1 minus 1. 2 times 1 is what? 2 minus 1. Is it not giving me 1? It's all about what? Arguments. So we have P of 3 is true. Now we say 1 plus 3 plus 5. Will you give us this n squared? Let's check. Is equals to n squared. 1 plus 3 plus 5 is what? 9 is equals to. Remember our n is what? 3. 3 squared. 9 is equals to 9. Proved. Wow. We have proved it. We are not finished. Okay. So this is the first step. I'm tired. I don't want to argue again. Please. Mathematical induction or what? I don't want to argue again. So let's clean this place. This argument. Hey, so what we are going to do now is we are going to assume that let me write it. We assume that P of K is true for the mathematical induction hypothesis. We are going to prove another thing. All this thing is just what? Proving. I'm tired though. We assume that P of K is true for the mathematical induction what? Hypothesis. So we write n is equals to what? K. And P parenthesis K plus 1. This is the what? The formula. Now let's prove. We have 1 plus 3 plus 5 plus 2n minus 1 is equals to n squared. So this time around, anywhere you see n, you put what? K. We have 2k minus 1 is equals to k squared. We have 1 plus 3 plus 5 plus 2k minus 1. Now, at this second time, anywhere you see k, you put what? K plus 1. You understand this now? So we are going to have 2. We are going to have 2 let me just write it like this. 2 parentheses 2 k plus 1 minus 1 is equals to k squared. Now let's go ahead. Remember that this thing is equals to what? K squared. So we can replace this whole thing with what? K squared. So we're going to have k squared. Let's open this parenthesis. 2 times k is what? Plus 2k. 2 times 1 is what? 2. Then minus 1 is equals to k squared. So let's proceed. So let's finish it up. This place. So you have k squared plus 2k. 2 minus 1 is what? Plus 1 is equals to k squared. They are telling us that this side must be equal to what? This side. So let's finish the argument. We started it together. So we are going to have 2k squared plus 2k plus 1 is equals to. Remember this k squared. Okay. See what I'm missing? This k squared. Anywhere you see k, you put what? K plus 1. So we missed it at this step. So we are going to have k plus 1 squared. Are you seeing it? K plus 1 squared. Then k plus 1 squared. Are you seeing it now? I know you are seeing it. So let's continue. Let's continue. Let's continue. So we have sum of two squares, k plus 1, k plus 1, right? So we have k squared plus 2k plus 1 is equal to k times k squared, k times 1 plus k, 1 times k plus k, 1 times 1 plus 1. So we have k squared plus 2k plus 1 is equal to k squared, k plus k, 2k plus 1. Proved. Are you seeing it? So this side is equal to this side. So we are correct. We won the argument. Thank you, mathematical induction. Maths is fun. Please follow us on our Facebook page, TikTok, Instagram, and the rest for more videos.